Hello guys and welcome to the video of explanation of the mini industry automation system in GXWorks code and the result show. And now let's take a look at the code first. And here we have the final code that we have finalized is already, but we can improve it a little bit, but after this one for sure. Firstly, I'm going to explain like briefly, but it will cover all the information that in this code will have. Okay, first we want to collect the data of the position of the step motor and the current positions of step motor. So first one is the 8340. It's the data that's collect the position of the current the current position of the motor. So we give it in D0, and this one is also K3000 is the positions of post 1, and this post 2, post 3, and post 4. And now we have separate the input list, output list, the switch sequence, and the switching conditions, and we also separately the step module functions. Okay, first let's take a look on the input list. So we have created all the input lists into one section so we can easily pick it up to use. So like example, we use an X003 to work to activate on M203 or toggle switch of emergency. So we don't need in these sections we doesn't create the whole self-hold switch yet, because we create in the switching and conditions. So as the example, we create this one M203 to activate as the toggle switch, the toggle emergency switch. And we also comment in right here, and we found that if we comment right here, it will show in every single one that we use this M203. Okay, and then X4 button start, and also this one you might confuse, what is this? This is used for the monitor. The monitor has to send the data directly to the PLC to activate one of the specific that we have config in the studio of the monitor. So we define it as M3100, same as the bottom start, bottom stop. Yeah, right here. And the order is like bottom alarm, subswitch order, probe high sensor, probe low sensor, the workpiece checking and real sensor, material sensor, and also the eject sensor, and vacuum nozzle sensor, slide put sensor, slide return sensor, kick back sensor, kick go sensor, probe up sensor, probe down sensor, nozzle up sensor, nozzle down sensor. Okay, and let's move to the next sections. The next section is the switch and condition sensor. Okay, as I told you that in these sections we're going to have a self-holding system like this one. The button start or M204 will activate M0, so it will self-hold like this. And also we have prevented by button start, button false, button alarm, and subswitch auto, and also M51 or emergency stop switch. In emergency stop switch, we have put it in every single line of the code to stop the work. Okay, so if you push on the emergency stop right here, all the code will be stopped. But if you push bottom stop, it will reset. After you pull out the emergency stop and push second stop button, it will reset all the work and return all the object or the component to home position, and you can place start right here. And also same as the auto switch, yeah, bottom align, bottom false, subswitch auto is like toggle switch, so we don't have to create a self hold. And now is the conditions. How do we check that there is a workpiece in a cylinder on the slicer? So we have a sensor of the checking workpiece, which is M211. We also facing the if we have like we worked on one workpiece, right? The slicer will push out, and then whatever it do is it will activate again because of the cylinder has it's the sensor also detect the cylinder the slicer too. So we will create like this one. I will explain after this, but I will explain this briefly. Is that like we have to reset the value of it after the work cycle is done. So like the condition hole, the metal piece is placed, plastic piece is placed, or M1. M1 is the button stop or emergency stop or button start button. And now this is the condition that we use on probe to check that the workpiece has hole or not. Okay, and in this one we have T12. T12 is what? T12 is the wait time before collecting the data, because of some error due to the bouncing of the probe will create a little bit of, not a little bit, a lot of error. So we have to wait a little bit of time and then collect the data. So probe low and high. Low and high is like we have two encoder, right? Yeah. No, we have two AR sensors. So the probe is like detect 1 and detect 2 for each level. So if it's a plain piece, it will activate both low and both high and high sensor. So it will activate both, and then we self-hold it to remember that M7. If the M7 is activate, it will be a plain piece. It plain piece, and then same as the piece cutting out reset value of this one by end of the cycle duty, and also emergency button. And this one is the whole piece. Whole piece is like it only needs to be detect the probe low sensor only, not probe high. If probe high is working, this one will not working, right? Because it's closed gate. And now the start of the sequence program. So M0 is the bottoms, is the self-hold start button. M0 right here, and start. M10 is right here. Yeah, M10 is right here. I will explain it later on. No, this M10 is when you activate this one. When I will explain the next step. Okay, let's take a look at this first. Okay, I'm sorry. M0 activate, and M5 is what? The workpiece. Yeah, M5 the workpiece. Is there a workpiece? It will activate. So M0 M5 activate, not activate, not activate. M2002 slicer will push out, and will push out why it have M5 in there. Okay, and then it will push, it will on right here on 2, and then the we create the to prevent all the errors, so we have to add the M219, which is the sensor of the kicker. The kicker have to be in the back to prevent that if the work, if it's still out there, this step cannot be worked. Okay, and then it will push until the slicer sensor push will activate, and then all activate, and this one activate, and it will go right here. M10 will activate and cut out this one. So M202 will not work. And this is the step that work that are all the same. Yeah, all the duties, all the sequence in this code is this work as the same. If the first sequence is work and then finish this job, and then the second has start, the how do you say it, the output will turn off by cut out this one, but all the sequence will activate, so the next step can be activated too. And now for M10 is on, and then what, probe will be down, probe, and then when probe down, kicker is back too, okay, to prevent it, and probe down to the sensor of the probe down to M211, and then M10 is still working, and this one is to reset the value when we need to restart the cycle, and M11 will activate. So in this case, if the probe is down, right, this condition will work and collecting the data. Yeah, so we can use in the conveyor sections. So when M11 is activated, K T10 and T12 will activate. T10 is to wait for probe down like 1.5 seconds to make sure that there is no bouncings or it's down, it's how do I say it's put in the hole correctly, and then this one is to wait for collecting the data. And now if M10 is like the next step of us, so M10 is activated, now the probe will be up. Okay, the probe will be up, and you might think that why M1 is here. M1 is what? M1 is button stop or duty cycle stop. So if we put the duty cycle stop, all the thing will return to its positions. So to what? To what? To make all things simple and return to the base position. So probe need to be up, M1 activate probe up, and also it will activate like slide return. Yeah, right here in the next step. And now when the probe is up and the sensor is up and it reaches the sensor, M11 is on right here. Cutting how do you say, resetting value is off, not yet, and M12 will be on. And M12 on, the kicker will kick it, will kick the workpiece out, and the kicker go, slicer also push, and kicker reach the kicker advanced sensor. So it will activate M13, and M1 will activate M13 too. Why? Why that? I've explained previously, but I'll explain again. Because M13 will activate the slicer to return also the kicker, because we're too lazy to create more sequence. So one memory, create two, and M1 come activate this one, also return. Yeah. And now when the slicer return, kicker return, or reach its sensor, both slicer return sensor or kicker back sensor. And also M13 is working, and this one is the resetting memory value. M14 will work. M14 is what? The conveyor. Yeah, conveyor is work. And now the conveyor pass is a little bit confused. Firstly, the whole piece, okay? So the whole piece, right? The whole piece. M6 will only act the activate of M6 and M7 right here. The M6 will be the only one that activate, and this one should be deactivate. Okay, and then it will go in this condition, not this condition. Okay, and then this one conveyor forward will go until the eject sensor. Why it needs to be closed? Because of in the stations it's like the value is invert, right? Yeah, if we turn on, it turn off. So we need to switch it a little bit, but it's work the same. Like it will move forward and then stop when it reach the eject sensor zone, and then it will activate as the same of the other sequence. M15 will activate, and then eject or the pneumatic function that will push that workpiece away, and then push until the eject zone sensor doesn't detect anything. Okay, but this is some kind of a reverse kinetic. Okay, and then it will activate M16, and when M16, yeah, I name it like end condition hole. So end condition hole will reset all the value and start the new sequence, right? Yeah, M16 reset, M0 M M16 reset, right? Yeah, and this one cannot be working. Yeah, this one cannot be working. So it will restart this one, and then go around the game. All right, it will go around the game. It's like it's reset all the value. So as this one, right, at this one is still working all the time, but if this one is activated, this one cannot be working. So this one, the first one, can be working right now. So it will work and work and work and work again. And now here come the plain piece. The plain piece is also like the same one, but it's need to activate both of it, right? Yeah. And now the conveyor will move forward until it's the end real sensor will detect and activate M17, right? And M17 will activate delay. Why delay again? Because in some case that the conveyor is stopped immediately and the workpiece is not in the center for the next step in step motor, right? So we need to have a little bit of delay, and that's all the first half of the section. And then we put right here the output list. Yeah, as we define by ourselves. So the kicker go 120 M2000, and if the kicker go cannot be is working, kicker back cannot be working right here. Yeah, and M3320 is used in the monitor. If we push because we create a monitor that can control all the component, right? If we push the bottom that name like kicker go button, it will go. So cannot be activated at the same time. So this one is kicker go button and re reset value by kicker back buttons. And also it's a self-hold system. Same as the other. No need to worry so much. Okay. And now. This one, you might wonder, how do we going to control the conveyor? So here you go, the memory that activate the conveyor. So we have two output, right? The conveyor forward and the conveyor backward. Yeah, and this one is memory to use on the monitor to push the button and conveyor will go forward. But with the same speed when we work on the site or our site duty cycle. Yeah, and this Y14 will activate, and then here the PWM, because all the motor controlled by PWM, like K80 and K100, like the duty cycle is 80% per 100, and Y001 is like pulse of it, yeah, in the directions. And now the jogging system is working. We created for a created for monitor. Yeah, for monitor. Jogging is for monitor. Like M3001 is when you place jogging plus, it will go like 3000 pulse. I think it's a like pulse, and with the speed 250 in the pulse x axis and y02 or the output of it. And also this is the jog minus. Yeah, the position is like the pulse is like minus 3000, and this is the positions of the step motor. We use the RVA to create a drive absolute positions like 2k to k 250 is like that in at that position with the speed 750, and the same pulse in x axis and y double to the output of it. And this is the memory that to activate the position 4 and prevented by all the things. And also this tool, if you place on this tool on the screen, this one can work. And also if you place on position 3, you cannot place on the other position like home, post 1, post 2, post 4. And if you push the emergency stop, everything will stop too. And also jogging plus and jogging back. Yep, yeah, yeah, man. Also the DRVA also to move in the absolute position. We could use a D, right? Yeah, D. This one can be D303. Oh shoot, forget about it. Yeah, right here we can use like this, but there's some kind of, but the value of the 323 is in the top of our code, right? Yeah, right here, the post 1, the post 4. Yeah, right here, K25. We can use 2, but in this case we have to use some kind like this because of debugging. Same as the order. And now let's continue on our all other duty cycle sections. If the embryo is detecting something, it will activate the step motor to move in the post 1 right here. Okay, and then this one is is the memory to check that is the nozzle width, is the vacuum, okay, is there vacuum, is there workpiece, is the vacuum, right? And now if it's in the position 1 already, the nozzle down will activate. It's like you have a reel like this, right? And this is your step motor, and this is post 1. Boop, boop, and you have check it. Wow, M302, check it, and the nozzle will down. M30, and it will vacuum. And this is how we check it. We use equal D0 or the current position equal to D302 or the post 1. Yeah, right here, and post 2, post 3, post 4, and post 5. We have to create a range because of the motor. When we send the position, the absolute position to it, it will have a little bit of error, like 20 plus minus 10 or 20. Yeah, so we have to create it lane range. And now, right? And this also when the NVL sensor is on, it go to post 1. And then if post 1 is on, nozzle will up, right? The nozzle, some kind like if the base position, the first position is not in the position 1, so it's might the nozzle of the vacuum might be down, so we command it to up, and then go right here, and then down. Yeah, and then down, and then down, and after it down and down conditions, after it's down, it will do whack. It will pull out the workpiece and then move to position 2, right? Yeah, and this one, and it will activate the nozzle up and then move to position 2, and then it will work on the position 2 again by nozzle down, right? Nozzle down. And when the nozzle is down, it will check that if what is its material, which is metal and plastic. So checking is done. Oh, checking it on, then what is it? The material sensor would activate. So this one activate, and then this one activate. It will delay like 1 second, and then activate this one, and then go to the next step, M33. And then in this end, it's a different case, like if it's not detect anything, it still work on because it's closed gate, and then wait 1 second and then go M35. And now M33 is working, go to position 3. M35 working, go to position 4. and then hold on a little bit and then let it go, right? Let it go. T1, do nothing with whack. Whack is done, don't do whack. And then if both of T1 T2 is working done, so return to home position, and T1 and T2 right here, as you can see in this, in sequence code. Yeah, you might have this one. Yeah, if the work is done, it will reset all the value and redo the work cycle. And now let's see the result. Yeah, I talk too much. I have talked too much right now. And this is our monitor, which have a start button, reset button, and also stop button. In reset button that we create in additional to work on the component command, because sometimes the error codes the error is due on we need to reset all the value by pushing the stop button, and we need to cancel the stop button, which is self-holding, by click on start button. But if we click on start button, the slicer will activate. So we create one button which is reset. It's reset the value of the second stop button, but not start M0. And then we create the step motor, slicer control, kicker, conveyor, ejector, probe, vacuum. And now I will show you. This is the result. Here in the step motor phase and position, home, post 1, post 2, post 3, post 4, and current position, and each specific position of post 1, post 2, post 4, and then to next piece. So kind of like that. Here, see result. This guy so why this guy so slow? Sorry. See, if you click it, it will work. See, work absolute position. And here is the part where we control each component. This one, slicer, push right here. You see? Yeah, push and return. And now the probe up and down. Yeah, this probe is down, this probe is up. Yeah, we can control it easy. And now let's take a look on how we start the work. Okay, we place on cycle stop and make sure by place on reset button and then click start. If you slide out right here and then push out, yeah, this one is the plain workpiece, right? Yeah. Then you pull up, checking, and wait, and then throw it away. Yeah. And sometimes in this robot we have a little bit of failure because of the probe didn't hit hard enough for the metal workpiece, which can be error that will create it, that will detect it as a plain workpiece. See? Yeah, right here, so smooth. The one who write the code is so smart, so beauty, so cool. Yeah, you see, and that's one is the detections of the eject, and then it will eject. But this setup is like only for the plastic workpiece. Yeah, it is the plastic workpiece will have a lighter weight. It will immediately eject, but for the metal which heavier, it will have like it will go like angular way, and then it fall out. Yeah, it's not big enough right here. Then it's all done. Thank you, and see you in the next video.